Okay, this video is to talk about how equations are balanced and how we can balance equations using something called an algebra scale. So let's take a look at what some of these scales look like. So just any scale can be used as a model. And so an equation in algebra is something with an equal sign. So it could be anything like 2x equals 4, it could be x equals 1, it could be 2x squared plus y equals 3. Okay, anything with an equal sign is considered an equation. And so when we're using our balance scales, what we're saying is that this middle part to our balance right here, that's the equal to sign. Okay, so that means if we're looking at this equation here, this 2x plus 4, it means that the equal sign is right here in the middle, and we're saying that what's on one side of the scale equals the other side, which means that our scale stays balanced. Okay, it doesn't lift up or go down, okay, because it's equal. So that would mean that the 2x would sit on this side, and the 4 would sit on this side. Now the same thing would happen if I was using x equals 1. The x would sit on one side, the equals is in the middle, and the 1 would be on the other side. And you can notice my scale is staying steady. It is not heavier on one side than the other, which is why we call it a balance scale. Our equations are always balanced. Now if I'm using this kind of crazy equation that we're not quite used to seeing yet, 2x squared plus y equals 3, the same thing happens. The equals is in the middle, the 2x squared plus y is equal to 3 is on the other side. Now if we think back to yesterday's activity with those algebra tiles, we know that x squared is 2 of these guys because there's 2x squares. So x squares are those square shapes and there's 2 of them. And we're adding it to a y shape. Well, we don't have a shape for a y yet, so I'm just going to put a y because it's 2x squares plus a y. There they are. So on this page I'm going to model using either algebra tiles or some sort of a shape representation for our equations. So remember we talked about equations having an equal sign. So an equation might be something like 2x equals 4. I can use algebra tiles and I can put them on this scale, or I can use these little pieces that I have, and I can say I have an x piece and an x piece. And if I had algebra tiles, remember, these guys would be these long rectangular x pieces, right? And my constants are the little squares that are my 1 units. I'm putting these guys all on top. I'll just stack them here. Okay? Now, if I want to draw it out, my algebra tile says they are constants. They're these little squares. Are these like terms? No, they are not like terms. And you can tell because rectangles are not the same. They are not alike to those little tiny squares. So they are different terms. They cannot be combined. But they can balance each other. And so my scale is balanced because of that equal sign right here in the middle. What's on one side is equal to what's on the other side. So if we take a look at our x pieces, I have 2 of them. Well, we know the x's are the same. They're both x's. They look exactly identical, but they're equal to something on the other side. So if I break these guys into 2 separate groups and I put one higher and one lower, I can say, all right, let's see what x can be. Well, let's take our pieces and break them into 2 groups. So I put 2 higher and 2 lower, and now that I can see that if I've broken my x into these 2 groups, it matches up with the 2 groups that I broke my units into on the other side. And so we end up with an answer of x equals 2. Because when you separate them out and you want to find out what just this one x is equal to, you can see that he's paired up with this other grouping that we made. And I'll show you the algebra to it in a minute. Okay, so instead of having a picture, I'm going to show you how we can do it algebraically, both with our algebra tiles or just with numbers on our paper. So we're going to divide our paper into two sides. On one side we're going to use visual, and on the other side we're going to use real algebra. So first we're going to start with our original problem. And our original problem is going to be 2x is equal to 4. It's the same problem that we just saw. So we actually know what the answer is. But that's okay, because we want to model it using our steps in both manners. So if I want to model it, then I'm going to say that my x pieces are these rectangles, and I'm going to draw them. And they're equal to my 4 little constants. Okay? And now what I need to do is I need to say, okay, well, I don't really want to know what 2x is equal to. I'm always trying to figure out what 1x is equal to. Well, if I want 1x, then I need to separate them. I need to take these two x's and I need to put them in their own groups to figure out what each one is equal to. So all I did was move my 2 that I had here into their own groups. And so they're still there. They're still on the left side of my equation. But when I break something into groups, I'm actually dividing, okay? Because that's what we learned in 3rd and 4th grade, that when we break things into smaller groups, we're really dividing. If I take 12 pieces and I break it into 3 groups, I have 4 in each group. 12 divided by 3 is 4, okay? So same thing, I have 2 x's and I'm breaking them into 2 groups and I have 1 piece in each group. 2 divided by 2 is 1. But if I do this to the one side, I really have to do it to the other side to figure out how they match up. So I'm going to take my 4 little 1 units that I have here, and I'm going to break them into 2 groups, just like I did on the left side. And now I can see that this is my final answer. I have figured out that x is equal to 2. Okay, now let's do it with the math. Do it algebraically. And we're going to say, okay, we have 2x equals 4. Well, I don't want 2 x's. I want 1x. How do I get 1x? In order to get a 1x, I have to get rid of this 2. Well, it says 2 times x. The opposite of multiplication is division. So I'm going to divide by 2. Divide by 2. Because remember, a fraction is really division. But if I do it to one side, I have to do it to the other because otherwise my scale tips and it's unequal. It's not balanced. So I'm going to divide by 2 on the other side. So I'm left with 2 divided by 2 makes a 1. So I'm just left with that x. And then I have my equal sign. And of course, if you do it to one side, you have to do it to the other side because that's the only way our scale will stay level and stay balanced. So 4 divided by 2 is 2. And now I have my final answer. So I'm going to show you something that's another way that we're going to use in our classroom tomorrow. We're going to use this hands-on equations mat. It looks just like this one. And we're given some little pieces. So this piece here, this is our X piece. So this little pawn or little figurine guy, we're going to call him our X's. So he's basically representing that rectangle of our algebra tile. So he's our x's. And so if I have 2 of them, then what I really have is 2x. So mathematically, I could say that on this side of my equation, so on this side of my equation, I really have 2x right now. And remember, the middle of my balance is my equals. This balance has to stay level. So I have to figure out what it's made of. And so what I'm going to do is I'm going to show you what we represent the constants with. So this little cube guy, it's actually a dice with the number 4 on it, represents my constants. And so I have the equation 2x is equal to 4, represented in a different way, a different kind of model, a different kind of manipulative to use. But the same thing happens. In order to figure out what 1x is, I have to break these guys into 2 pieces. So I'm going to separate them and say I have one group of x at the top and one group of x at the bottom. So essentially I've divided it into two groups. So again, I've divided by 2. But I need to do that to the other side. And that 4 is one dice right now, but really we know it's 4 little pieces. So I can actually change him. I can change him to a 2, and let me get another one, another 2. And 2 plus 2 is really 4. So I still have 4 on my equation, but I have two groups that together make a 4. So what I can do then is I can separate it out and make it into two groups. And now I can see that I've taken this right side of the equation that was 4, and I've said, let's break it into two groups. Let's divide it by 2. And so I show it mathematically as divided by 2. And my end result is that each group ends up with the same thing. X equals 2. And x equals 2 is then the solution to my equation. So what we're going to do is a little bit more complex problem. Notice that we don't just have x's on one side, we have 3x plus 4. So that means we have our little x's, but we also have 4 constants, okay? And on the other side, we have 19, but this scale is balanced. It's 100% equal. That's what the equal sign means. Balanced scale. It's not tipped. Well, in order to break my x's into their groups, I have to get rid of that 4 because 4 doesn't break into 3 groups evenly. It doesn't work out. We'll have a remainder. So we can't, if we just say, hey, I'm just going to get rid of him, my scale tips. This side goes down and this side goes up. Well, then my equation isn't balanced. And remember, our whole process is to balance the equation. So what I need to do is I need to find a way to get rid of this 4, but keep my scale balanced. Well, I know he wants to go away. He has to leave. He can't break into 3 groups. So I'm going to get rid of him. I'm going to subtract 4. 4 minus 4 makes 0. That would make him disappear. But if I subtract 4 on this side, on the left side, my scale is going to go down, and I don't want that. So in order to keep my other side from going up, I need to subtract 4. And now I've lightened my scale by 4 on both sides, so it's 100% balanced. So 19 minus 4 is really 15. So right now I have 3 x's on this side, and it's equal to 15 on this side. Well, I need to know what 1x is. So I'm going to break it into 3 groups and figure out what each of these x's are equal to. And since they're the same thing, that means this 15 has to break into something that's the same thing. So 15 can be 1 and 14, but I can't put a 1 here and a 14 here and say that x is equal to 1, x is equal to 14, x is equal to 0. That doesn't work. But 15 is really 5 plus 5 plus 5. So when I break 15 into 3 groups, or I divide it by 3, I end up with 5 plus 5 plus 5. So that means that each of these x pieces is equal to 5, because these 5s can move into their own groups. And now I know that x is equal to 5. And what I want to do now is I want to check it. I want to make sure it's right. So to make sure it's right, let's do it algebraically. Let's get rid of our 4. We're going to add a negative 4 to both sides. Remember, we have to keep it balanced, so we have to do it to both sides. And this equal sign is the middle of my equation. So I'm keeping everything on the left and the right side. Well, 3x plus 4 minus 4 means that this 4 is gone. Plus 4 minus 4 is 0. So I'm left with a 3x, and it's equal to 19 plus a negative 4. 19 plus a negative 4, or 19 minus 4, is really 15. Now I have 3 times x. That means I have 3 x's. I want to put them in 3 groups so that I get 1x. So what happens is if I divide 3x into 3 groups, 3 divided by 3 is 1. That means I have 1x in each group. But if I divide something into 3 groups on the left side, I have to divide it into 3 groups on the right side. And 5 divided by 3 is, 15 divided by 3 is 5. My answer is x equals 5, which is what we solved. So now we want to check it. And I want everyone to make sure they understand how to check it because you're going to be required to check in class. So we take the original problem, 3x plus 4 equals 19, and we're going to solve it. We're going to take this 5 and we're going to plug it in for that x. And so we're going to say 3 times 5 plus 4. And we want to make sure it equals 19. Well, 3 times 5 is 15. And then I have my plus 4. And 15 plus 4 is 19. And 19 is equal to 19, which means that we did the problem correct, and it is correct. We've checked our work. So it's your turn. I'm going to give you a few problems. You're going to write the equation on your paper. You're going to model it with either algebra tiles or the little shapes with the dice, however you want to model it in a picture format, and show the steps of how you get the right answer. And then on the right side of your paper, you are going to do the algebra. You're going to box your answer. You're going to check your answer just the way that we did. So let's take a look at the problems. So here are the 5 problems that I want you to do. I'm going to do number 1 for you to show you exactly what I want. Okay, so we talked about the box 8 in class, and so I want you to use that with these notes and with your homework tonight. And basically, you have a box side by side, one on the left, one on the right. And so on the left, I want you to model it using a picture, and on the right, I want you to use your algebra. So on the left, let's go with our picture. We have an x, and we have 3 pieces, and it's equal to 20. So we have to draw out 20. So now I have modeled x plus 3 is equal to 20. So these 3 little constants that I have here, they can't break into a group with that x, so we have to get rid of them. So in order to get rid of the 3, I really need to make a 0. It needs to be x plus 0. Well, plus 3 and a minus 3, which remember in algebra tiles we show as the red color, we would add 3 negatives to this side. And if we add 3 negatives to this side, my scale just tipped. So if I do it to one side, I have to do it to the other side. So I'm going to add 3 negatives to this side. Now my scale is still balanced, but remember, 1 positive and 1 negative make a 0. 1 positive and 1 negative make a 0. 1 positive and 1 negative make a 0. And we can do the same thing on the other side. So what do I really have? I have that x left, and I have 17 pieces. I'm not going to draw them out. You can draw them out. Okay, but that's my final answer. So now let's go do it algebraically. We have x plus 3 equals 20. And remember, I need to move that 3. So again, how did I move the 3? I added the opposite. I put in those negative pieces. So if I'm adding the opposite, I'm adding a negative 3 to the left. But my scale tipped. So to keep my scale balance, I have to add a negative 3 to the right. And now I can show it as a plus 3 and a minus 3 is really a 0 pair. They're opposites of each other. So I'm left with an x on the left is equal to a 20 plus a negative 3 is a positive 17. So I can box my answer, and now I'm going to check it. And remember, this is the last step. You have to show a check. So to show the check, you write your original problem, and then you take your answer here and you plug it in for your x. So in your next step, you would say 17 is what I'm plugging in for x, plus 3. What is 17 plus 3? It's 20, and that does equal the 20 it's supposed to equal. So I've just proven my problem correct. So here's your 5 problems. We just did this one. So you're done, and I've modeled it the way that I want it done, both ways, with picture and with algebra, and then of course the check. So you can go back in the video if you need to double check the slides or you need to watch anything, but you have 4 more problems to do. And just remember, these are the steps that I asked you to do. Write the given equation, model it, show all your steps with your model, and then do the algebra steps in the right column. So on the left, you're going to do the equation, model it, show the steps, and then on the right, you're going to write the equation, use the algebra steps, box your answer, check your answer. Okay, bring it to class tomorrow.